In this video, I will discuss a JEE Advanced PYQ from the topic alternating current. This question is based on sinusoidal variation of voltages and currents and their RMS value. Consider a general circuit. There will be a voltage source and there will be some circuit elements, some resistors, inductors, and capacitors. This voltage source will have a particular frequency, say omega or F. The interesting thing is all the voltages and current at any point in the circuit or voltage across any elements will have the same frequency omega. The frequency will be same, it will not be different. A sinusoidal variation is a variation like this. So we have amplitude and a time period. This is a function of time, and frequency is reciprocal of time period. So the frequency of all the variations, voltage and current, will be same. F, and F is related to omega is 2 pi F. F is in hertz or per second, omega is in radians per second. But the amplitude and the phase will be different for different voltages and currents. Phase is the point which corresponds to t equal to 0. For example, t equal to 0 can be this point or here, anywhere. So that is the phase. So phase can be different, amplitude can be different, but the frequency is same for all the quantities. And for a given AC variation, we can define an RMS value which will be at this level. So this RMS value, for example, suppose this is voltage variation. So this much is V0. So VRMS will be less than V0 by a factor 1 by root 2. And this is less than 1.707. We can derive this relation. So RMS means root mean square. So first you have to do the squaring and then do the mean and then take the root. So for example, if you take this voltage variation V equal to V0 sine omega t, if I square, I have to go in this direction to find RMS value. First you have to square. So this will be V0 square sine square omega t. Then you have to find the mean. Mean with respect to time. So this much is there for this particular time instant t. So for a small amount of dt about this time t, the value of this is sine square omega t dt. I have to add for all dt's. So if I add this for all the small time intervals in the interval 0 to t and divide by the total time from here to here, which is the time period t, this will be the mean value. First I have squared here, then this is taking the mean, and after taking the mean I have to take the square root. And then if I take the square root of this thing, I will get the RMS value. So this one, V0 square is constant, not a function of time, will come out by t. Integral of this sine square I can write as 1 minus cos 2 omega t integral dt. So this has got a frequency of 2 omega. Any sinusoidal variation, if you take the average, it will be 0 because positive and negative quantities are same. So double the frequency, that also will have equal positive and negative. So this part, the average will be 0 when you take the average. So only the first term will contribute, it will be just dt. So I'll have t, and in this formula there is a half here. sine square is 1 minus cos divided by 2. So I'll get t by 2 into this one. So that will give me v naught square by 2. Now if we take the root, I'll get v naught by root 2. So this is the RMS value of a sinusoidal variation. Here I have taken the example of voltage. So first you have to do the squaring, take the mean with respect to time. So this is there for time instant t, that is there for a short time dt. You will sum them up and divide by the total time t. This is taking the average mean. So do this thing, we are using sine square as 1 minus cos 2 theta by 2, where theta is omega t. And this term will be 0 because equal positive and negative quantity. So the RMS value is 1 by root 2 times the peak value. So with this understanding, you can solve this JEE Advanced question. Timestamps are given in the description box. You can watch parts of video if you are running short of time. This is the question. You can read it. The instantaneous voltages at 3 terminals marked X, Y and Z are given by Vx equal to V naught sine omega t, Vy equal to V naught sine omega t plus 2 pi by 3, Vz V naught sine omega t plus 4 pi by 3. An ideal voltmeter is configured to read the RMS value of the potential difference between its terminals. It is connected between points X and Y, and then between Y and Z, the readings of the voltmeter will be option A, Vxy RMS value is V naught into root 3 by 2, Vyz RMS value is V naught into square root of 1 by 2, option C, Vxy RMS is V naught, option D, independent of choice of the two terminals. You can pause and run this question. So option A, Vxy means Vx minus Vy. So first let me check option A. It's multiple choice, more than one correct answer. So Vxy is Vy minus Vx. So this is these two subtract, we have to subtract. So that will give me V naught into sine omega t plus 2 pi by 3 minus sine omega t. So to use the formula sin c minus sin d, sin c minus sin d, this is a trigonometric identity which is 2 cos sine, and this cos will be angle c plus d by 2, and this is c minus d by 2. So if you use that thing here, I'll get 2 v naught cos this plus this by 2 is omega t plus pi by 3 into sine differences, omega t will go, just pi by 3 will remain. So this is a function of time because these things are instantaneous voltages, they are a function of time. So here only this thing is coming up. Pi by 3 is 60 degrees, pi is 180, and sine 60 is half. Sine 60 is root 3 by 2, sine 30 is half, sine 60 is root 3 by 2. So I have root 3 times v naught into cos omega t plus pi by 3. Root 3 by 2, 2 and 2 will cancel, root 3 will remain. So this cos and sine are same sine sinusoidal variations with a phase difference of pi by 2. So this is also a sinusoidal variation. So if I take, and the amplitude of this variation is root 3 v naught. So the RMS of this time varying quantity will be less compared to the peak value by a factor 1 by root 2. The peak of this thing is this quantity. This is a sinusoidal variation. So it's root 3 v naught. So root 3 by 2 v naught. So option A is true. RMS value of the voltage between x and y, which is Vy minus Vx. And Vyz, it's Vz minus Vy, difference between these two, it will come out with the exactly same thing. So root 3 factor is missing here. So B is not true. Option C is false because A is true. Option D, independent of choice of the true, this is true because Vxy, Vyz, Vzx, all three will be same. This can also be understood in terms of phasor diagram. Vx, which is V naught sine omega t, Vx, which is V naught sine omega t. So if I represent Vx like this, Vy is ahead by an angle 2 pi by 3. 2 pi by 3 is pi is 180 or 2 pi is 360. 360 by 3 is 120. So 120 degrees will be like this. This much is 120 degrees or 2 pi by 3 radians. So this is Vy. And Vz. 4 times 2 pi by 3 is 240. So this is 240, this should be again 120. This also is 120. So 360 degrees is split into 3 parts, 120, and each Vx, Vy, and Vz are spread equally. So Vxy is Vy minus Vx. So I have to subtract this, I have to negate this Vx, so this is minus Vx. Now I have to add these two. Vxy is nothing but Vy minus Vx. So Vy I kept like this, and this thing minus Vx I have written like this. So I have to add these two quantities now. This angle is 60 degrees because straight line is 180, 120, 180 minus 120 is 60. So it's like two vectors, angle between them is 60, and there are two equal vectors because the amplitude is same. So the sum of these two vectors will be in the middle by symmetry, and this angle is 30 degrees. So the component of this one is cos 30. So Vx, or I have to take the amplitude. The length of the vector is the amplitude V naught. So the contribute from Vy will be V naught cos 30, which is root 3 by 2, and then Vx, or the length of this vector is V naught, again root 3 by 2. So it is root 3 times V naught is the length of this vector. And to get the RMS, so this is Vyx. So this is instantaneous value. So if you take the RMS value, it will get reduced by a factor 1 by root 2. So from this I get the option A is the correct one. So instead of using the trigonometric identity, this one, you can also do this vector addition or vector subtraction, which is same as adding Vy and minus Vx. So this you also can get the result. So from here also you can see by symmetry, all these three vectors will be same. This is Vyx, this is V between Z and Y, this is Vzx. All these three vectors will be same. So D is also true. A is true, D is true. P and C are false. That is the correct answer. So I done here. Vxy is Vy minus Vx. Vy is V naught sine omega t plus 2 pi by 3. And Vx is V naught sine omega t. So this you have to use the trigonometric identity. Sin c minus sin d is 2 cos sine. And this angle is this plus this by 2. So it will become pi by 3. And sine is this minus this by 2, which is called sine pi by 3. So this is the sinusoidal variation. And this is sine 60, which is root 3 by 2. So I'll get root 3 V naught and this is the sinusoidal variation. So RMS value of a sinusoidal variation is the amplitude, which is root 3 V naught, multiplied by factor 1 by root 2. So this is the RMS value. So option A is true, B is false, and C is also false, and VXY, VYZ, and VZX are same. So option D is also true.